Although we focus mostly on the slope-intercept form of linear equations, it tends to be the most useful, there are two other forms that you should be familiar with. The first is called point-slope. The point-slope of the form of the equation is based on the idea of slope. We know that if to calculate slope, to do it all fancy, y sub 2 minus y sub 1, or y minus y, change in y over change in x, is equal to the rise over the run. In other words, the slope. So, if I were to say I have, I know one point is 3, 1, and I know the slope equals 2/3, I can use this information above to figure out what the equation of the line is. So, let's say I know that, so I know one of the points on the line. I don't know one of them, so I'm just going to call that y. I don't know one of the y's, but I know one y is 1. I know an x that's a solution is 3. So notice how it's the same thing. Change in y over change in x, and we know that this is equal to 2/3. This is just what we already know about the slope formula. If I cross multiply, I have 3 times y minus 1 is equal to 2 times x minus 3. And the final step in the point-slope thing is just so that I put the 3 over here. So it's actually 2/3. Sorry, I should write it like this. 2/3 x minus 3. So it's any y, the general y, minus the y you're given, is equal to the slope times x minus the x you're given. The general form, what we say, is y minus y sub 1, that's the y that you're given, is equal to the slope times x minus x sub 1. Okay, let's try another one. Let's say a point on the line is negative 2, 7, and the slope is negative 2. Okay, so plugging in here, I always leave this as the general, y minus the y I'm given, which is 7, is equal to the slope times x minus the x I'm given. Notice it's minus a negative, so if the point has got a negative sign, then you end up doing plus. And that's really all there is to it. Let's just do one more. Let's say I want to use point-slope. It's this form of the equation. And the givens are that so the point that it goes through is 1, 3, and the slope is negative 1. All this form calls for is just plugging things in. So y minus the y I'm given is equal to the slope times x minus the x I'm given. Ta-da! And that's it. That's for point-slope. The equation that you're going to be looking at tonight is called the standard form. And for some reason, everybody writes it like this. Capital A times x plus capital B times y is equal to c. So it looks completely different than what we were talking about before. But if I take, say, the equation y equals 2/3 x plus 7, and you want to begin using either point-slope or slope-intercept. But right now, this is not in standard form, as you can see, because we need a constant times x plus a constant times y, and that's got to equal a constant. So right off the bat, you can see that I need to bring the x's over here. So that means I have negative 2/3 x plus y equals 7. But a, b, and c all have to be integers. And fractions, as we know, are not integers. So now we're going to use the fraction destroyer. Because I can't have any denominators, I'm going to put the 3 over here because that's where I have room. That gives me negative 2x plus 3y is equal to 21. This is in standard form because it's a, b, and c are all integers. We have these two things on one side of the equation and then a constant on the other. So now let's start with some data and see what we... So we'll do 2 like this. In this situation, I'm given 4, negative 1 as a point on the line, and that m is equal to negative 2. Personally, I think point slope is the easiest, and plus it's helpful to get extra practice in the newest ones. So I'm going to say y minus the y I'm given, and minus a negative is plus. So y plus 1 is equal to negative 2 times x minus 4. Okay, we know that this is one version of the line. However, it's not in standard form. So I have to do exactly what you would think. First, get rid of the parentheses. And now I need my x's and y's on one side and my constants on the other. So to get the constants, I do this. To get the x's on one side, I add x, 2x. So I have 2x plus y is equal to 7. And now it is in standard form, a, b, and c. They're all on one side of the equation. Let's do another one. And again, I'm going to, just for the sake of space, I'm going to put it over here. It goes through the negative 7, negative 4, and the slope is negative 1/2. That's a negative. So, beginning with point slope, I'm going to say y minus negative 4, so that makes it plus 4, is equal to x. Well, actually, I forgot the slope part, sorry. Is equal to negative 1/2, and that's going to be x minus negative 7, which is plus 7. Whew, I hope I have room for this. Okay, again, fraction destroyer is handy. So we're going to multiply the whole thing by 2. That gives me 2y plus 8 is equal to negative 1. Actually, let's multiply by negative, because then I don't have to deal with that negative. So what that gives me is negative 2y minus 8 is equal to x plus 7. I could have done it the other way. I would have had a negative 1, and I would have had to change all those signs. So now I need to get my x's on the same side of the equation as the y's, and my constants over here, and that gives me negative x minus 2y is equal to 15 in standard form. So in general, the thing you need to know, with point slope, all you have to do is substitute into the formula. And the formula is y minus the y you're given is equal to the slope times x minus the x you're given. Okay? From there, to put into standard, you're going to have to get rid of your parentheses. Bring x's same side as y, and the constants to the right side. And then, if necessary, use the fraction destroyer to make sure that everything is an integer. By the way, there's more than one form to make sure everything is integers. It's possible that there's more than one form of a standard equation, but that because it depends on which Y's and X's you use, but we'll be clear about the directions in the homework.